The third geometry prerequisite is equations of lines. Here are some important formulas. Slope formula, you need 2 points to do this, is m equals y2 minus y1 over x2 minus x1. For point slope formula, you need a point and the slope, and you plug it into y minus y1 is equal to m times x minus x1. Slope intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. And finally, there's standard form. ax plus by equals c. You cannot have any fractions, and a cannot be negative. So here's an example. Find the slope between the points, -3, 6, and 4, -1. We're going to plug into the slope formula. So I've labeled my points x1, y1, x2, y2. So now I just take those numbers and plug into the formula. -1 minus 6 over 4 minus a -3. Well, -1 minus 6 is -7, and 4 minus -3 is 7, so I have -7 over 7, which is just -1. So now we have write the equation of the line in slope-intercept form and standard form between the points 2, 5, and -1, 6. Again, I've labeled my points so that it's easily plugged into a formula. We're going to start with our slope formula and plug in the points, 6 minus 5 over -1 minus 2, and I get the slope 1 over -3. So now I'm going to use my point slope form and plug into it. So I have y minus y1, which is 5, equal to -1/3, because that's my slope, x minus 2, my x1. As I simplify, I'm going to distribute my slope first, so I get -1/3 x plus 2/3, watch your signs, and then to get my y by itself, I'm going to add 5 to both sides, and I get y equals -1/3 x plus 17 over 3. This is slope-intercept form, but the problem asks us to go to standard form as well. This just means the x and the y values have to be on the same side of the equal sign. The x value cannot be negative, and we can have no fractions. So the first thing I'm going to do is get rid of my fractions. I do this by multiplying each piece by 3. So then I have 3y is equal to -1x, because all it does is get rid of the denominator, plus 17. Then I'm going to add 1x to both sides. I'm not leading with a negative, and I have no fractions, so my final answer is 1x plus 3y is equal to 17. And this is standard form. The third example, we have write the equation of the line in slope-intercept in standard form given a slope of 2/3 and the point 4, 8. So here we don't have to find the slope because it's given to us. So we're going to start with point slope form. We're going to plug in our point and our slope, and we get y minus 8 is equal to 2/3 x minus 4. Then I distribute my 2/3 and I get 2/3 x minus 8/3. I add 8 to both sides and I get y equals 2/3 x minus 16 over 3. This is my slope-intercept form. I have to keep going to standard form. So I'm going to get rid of my denominators by multiplying by the denominator. So then I have 3y equals 2x minus 16. And then I'm going to subtract 2x from both sides to get into standard form. Now I'm left with -2x plus 3y equals -16. The only issue here is that my a value is negative, so I have to flip every single sign and get 2x minus 3y equals positive 16, and this is standard form. For the final example, we're going to write the equation of the line in slope-intercept in standard form from the graph. So in the first one on the left, we're going to first find the y-intercept. It's -4. Then we need to find the slope. So we need to find another point on the line. This one is -3, -3. So when I do my slope, I'm going to do my rise over my run. It's 1 is the rise and 3 is the run, but this slope is going downhill, so it's a -1 over 3. Now I can plug into y equals mx plus b, and I get y equals -1/3 x minus 4. The two graphs on the right are special cases. If you get a vertical line, you should have x equals the number that it's going through on the x-axis. So this one's x equals -3. If you have a horizontal line, it should be y equals a number. And so here we're going to get y equals 3 because it's going through 3 on the y-axis. Now you try. Pause the video after each question, and then when you finish it, check your answer. It'll pop up after you hit play, and then try the next one.